what's up, 8th graders? So today you're going to be learning about graphing systems of linear equations, okay? Systems of linear equations can be a little complicated only because there's 3 different ways in which we can solve these. However, students tend to like graphing or systems of linear equations because there are 3 different ways in which we can solve these to get our answer, which is awesome. So let's kind of jump into it, and yeah, let me know if you have any questions. And so our warm-up today is you're going to graph these 2 linear or these 2 equations. And so that would be our warm-up. You don't have to do it, but that's kind of what we're doing for our warm-up. So let's kind of walk into our objectives today. First, you're going to solve a system of equations by graphing, solve systems from word problems, and then also we're going to learn some vocab words of systems of linear equations, solutions to systems, and points of intersections, okay? And that's what our goal is today. And so we have solved equations like this before, right? 2x plus 4 equals 12 and x minus 4 equals 5. We know how to solve them, solving linear equations, combining like terms, isolating that variable, all right? We found many solutions to equations like this, right? Oh, sorry, we have more. But we found many solutions to equations like this, right? Getting y equals mx plus b, or finding x equals something, right? We've solved these kinds to get them into y equals mx plus b form. And now we're going to be looking at what if we have one solution to 2 equations together like this. X plus 4y equals 12 and y equals 1/3 x minus 2. And what if there's one solution to both those equations, which means they have the same x and they have the same y, okay? And so let's kind of look at what that looks like. So our first vocab word is systems of linear equations is a group of 2 or more equations that are linear, and we use a set of mark, like as you see there, to group them, okay? So think about our introductory activity. What did you learn? So examples, we have all kinds of different ways we've solved linear equations, but we've only gone up to 2 variables. And so to get one solution, you need the same number of equations as variables. So if we look at this first one here, we have 2 equations, and we only have two variables, an x and a y. This next example here, we have 3 equations, but now we have 3 variables, x, y, and z. And each equation has those same number of variables, right? If we look at this one here, we have 4 equations, and now we have 4 variables, w, x, y, and z. And in order to find one solution for systems of equations, you need the same number of variables as there is equations. And that's how we kind of work with this. For this specific unit, we're only going to be working with 2 equations, so we only have 2 variables, which is nice for us to work with. So let's kind of go on to this. How do we graph these, and how do we find a solution? So here's how you graph systems of equations. Graph both equations, right? We know how to do that. Plus or minus b. On the y-axis, put a point, and then you rise over run based off what your slope is. Find the intersection, check your answer. And so we always want to make sure that we solve for y first. That's our goal for this. So in order to graph, we've learned to put in y equals mx plus b form first, right? So let's graph this first blue or this first red line, and then we'll graph the blue line. And so if we were to graph our red line, we would get something like this, right? We would first have to put in y equals mx plus b form first, right? And then we could graph this blue line, and you're going to say something like this. Your answer is that point where they intersect, okay? This point right here, 3, 4, is our answer. That's our answer to the question. 3 is our x, and it will come true for both equations. 4 is our y, and it will also come true for both equations. And we can check our work, right? We can check to make sure that is a true statement by going through our steps, okay? Let's try another one. We have our red line and we have our blue line. Let's go ahead and graph both, but you have to put in y equals mx plus b form first, so we have to subtract x. So you're going to have a point at -2, down 1 over 1, down 1 over 1. Our line's a little off, but you get the idea. And then our blue line as well, right? We want to put in y equals mx plus b form, and you're going to get a line like that. This point where they cross, they're only going to cross at one single point, okay? Our answer is going to be -3, 1. Okay, that's our answer for the problem. That's all I'm looking for. Let's keep going. Why is my slides not changing? I think that's all I have. You can go ahead and start the activity. If you have any questions on this, please let me know. But that's how you graph linear equations. The point where they cross after you graph both lines is your answer. So find that point, get your x, get your y. Let me know if you have any questions. Have a great day.